Hello everyone, I'm going to show you today how to find the line of best fit if you're given a certain amount of data, a certain number of statistics, and you're going to use equations to help you find the line of best fit, as opposed to using your calculator where you're given the whole list of data. Sometimes you're just given certain characteristics of the data and you have to find a line of best fit given from that. So in your notes packet, there's a problem section where it has some things here, and it looks like this. And it shows you that some things will be given to you. For example, x bar, y bar, the standard deviation of x, the standard deviation of y, and the r value. And so you're not given the entire set of data. Instead, you're just giving these major characteristics of it. And you have to come up with the line of best fit based off of that. So there are some equations there that you should write down. Y hat equals a plus bx, where b is given to you by r times sy divided by sx. And then you can see down at the bottom that a is given to you by y bar minus b times x bar. Once you've written those things down, then you can use those equations to help you figure out what the line of best fit is for that particular set of data. So also in your notes packet then, I want you to always remember that when you're talking about y, you're talking about the y is the actual, the observed value of the y. Whereas when we talk about a y hat, we're saying it is a predicted value of y. So there's a big difference there. Anytime you're talking about a y hat, we're talking about a predicted value. Anytime you're talking about a y, you're talking about an observed value. Okay, so now once you have that, you can use those equations. So on this piece, on your notes, you were given a list of data, a list of things. You were told what x bar was, you were told what y bar was, you were told what s of x and s of y and b was. And now that you have the equations, you can plug all those numbers then into the equations, and you can see I plugged them all in here using the equations that you just wrote down to figure out what your b value is. And then once you figured out what your b value is, you can plug that down here to figure out your a value using the equations that I just showed you on the previous page. And now that you know your b value and you know your a value, well, now you can actually go about figuring out your y hat. And then based off of that, you would be able to come up with a line of best fit for our data. And then finally, once you have your line of best fit for your data, a lot of times you'll be asked to make a prediction. So in this case, you're being asked to predict what the value would be at 50 miles per hour. So we would take our new line of best fit that we've come up with, our regression equation, least squares regression line is the technical name for it, and you would plug 50 in for x, and then you'd be able to make a prediction of how many accidents would occur at 50 miles per hour. And always keep in mind, this is merely a prediction. We're not going to expect it to be exactly that many, but it should be around that many, so you can make a prediction based off of your line of best fit. So we use this technique when you're given the characteristics of a set of data as opposed to being given the set of data itself. If you were given the set of data, of course, you would just put it all in your calculator and you would use linear regression on your calculator to get the exact answers. But sometimes on the AP exam, they don't give you all the data. Instead, they just give you the characteristics and you have to use the equations to go from there. So now that you've done one with me and you've seen how to do it, now I'm going to ask you to do one on your own. Good luck.